Hello everyone and welcome to this video. So in today's video we have a very decent limit question that is asking us to find the a if the answer for this limit is equal to positive infinity for x's approaching 1/2. So in this video we do have absolute value and we also have a square bracket which is equal to integers less than or equal to the value inside the square bracket. So as for the solution, we have to divide the x approaching 1/2 to x's approaching 1/2 from the right hand side and the left hand side. So first off, we will see what the answer for x's approaching 1/2 from the right hand side would be. The absolute value of square bracket 2/x⁴ minus ax minus 1 over 2x⁴ minus 3x plus 1. It is equal to positive infinity. So we do have positive infinity. It means that the denominator has to be equal to 0. So let's find the roots for the denominator. So to be able to find the roots for the denominator, or 2x⁴ minus 3x plus 1, we do have to find b squared minus 4ac. b is equal to -3, a is equal to 2, and c is equal to 1. So the answer for delta, or b squared minus 4ac, is equal to 1. Then, to be able to find the roots, we do have x equals -b plus minus root delta over 2a. And the x's would be equal to 1 and 1/2. So 1 and 1/2 would be the roots for the denominator. So we can rewrite the denominator as this: x minus 1 times x minus 1/2 times 2. So it will be limit of absolute value of square bracket 2/x⁴ minus ax minus 1 over 2 times x minus 1 times x minus 1/2. x's approaching to 1/2 from the right hand side. So x minus 1/2 when x's are approaching 1/2 from the right hand side would be positive, x minus 1 would be negative, 2 is positive as well, so the entire denominator is negative. We also know that the answer for this limit is positive infinity. So for sure, the numerator has to be negative. But let's see what the answer for limit square bracket 2/x⁴ when x's are approaching 1/2 from the right hand side would be. As I said, square bracket is equal to integers less than or equal to the value inside the square bracket. So x approaching 1/2 from the right hand side would be something equal to 0.500001. So the answer for limit square bracket 2/x⁴, x's approaching 1/2 from the right hand side would be equal to 2/1/2 power 2, which is equal to 2/1/4 positive, which would be equal to 7.99, something like that. And this square bracket of 7.999 would be 7. So we can replace this value as for the square bracket 2 over x power 2. So we would have limit absolute value of 7 minus ax minus 1 over a negative value. X is approaching 1 over 2, positive. So as we also said, the numerator has to be negative. So absolute value of 7 minus ax minus 1 is negative. That's one thing that we do have actually. Then let's go ahead and see what we do have is if x's approach 1 over 2 from the left hand side. Okay, so I'm going to rewrite the problem once again. This time for x's approaching 1 over 2 from the left hand side. So we know the roots for the denominator. So let's replace the roots that we have for the denominator and write the denominator as 2 times x minus 1 times x minus 1 over 2. X is approaching 1 over 2 from the left hand side. This is equal to positive infinity. X minus 1 over 2 would be negative. X minus 1 is also negative. So the denominator this time is positive. So the numerator has to be positive. But first off, let's find out what the answer for square bracket 2 over x power 2 when x is approaching 1 over 2 from left hand side would be. So it would be something like 2 over 1 over 2 negative squared, or 2 over 1 over 4 negative. So it would be something like 8.0001, and the answer for square bracket of that amount is 8. So the limit would be equal to limit absolute value of 8 minus ax minus 1 over 2 times x minus 1 times x minus 1 over 2 equals positive infinity. So the numerator is positive. Absolute value of 8 minus ax minus 1 is greater than 0. So let's combine these two things, these two inequalities that we found out, and see what we can get from it. So the first one is absolute value of 7 minus ax minus 1 less than 0, and the second one is a absolute value of 8 minus ax minus 1 greater than 0. And if you remember, the x's are actually approaching 1 over 2 or 0.5. So we basically need to replace 1 over 2 as for the x, and then go ahead and see what we can get. So the first inequality would be absolute value of 7 minus a over 2 less than 1. and the second part would be a absolute value of 8 minus a over 2 greater than 1. So I'm gonna multiply both hand side of inequalities to 2. So we will have absolute value of 14 minus a less than 2 and absolute value of 16 minus a greater than 2. So I'm gonna divide the problem into 3 main parts. A is greater than 16, A is between 14 and 16, and A is less than 14. So if A's are greater than 16, the second inequality would be A minus 16 less than 2, and the first one would be A minus 16 greater than 2. So A's are less than 16 or A's are greater than 18. So it will be like 18 less than A less than 16. We do not have any A's for that. So let's go ahead and see what we can get for A's which are between 14 and 16. So the first part would be A minus 14 less than 2, and the second part would be 16 minus A greater than 2. So for the first part we do have A's less than 16, and for the second part we do have A's less than 14. So we will get to A's less than 14. But initially the A's were between 14 and 16, so we do not have any A's for that. Let's go ahead for the third part. A's less than 14. So the first inequality would be 14 minus A less than 2, and the second inequality would be 16 minus S greater than 2. So the A would be greater than 12 for the first inequality, and the A's would be less than 14 for the second inequality. So A's would be in between 12 and 14. Initially we did have A's less than 14, so the A's would be in between 12 and 14, and the only integer in between these two values is A equal to 13. Thank you very much for watching this video, and I would appreciate if you could subscribe to my channel.